Hi everyone, this is Caitlin, and today I'm going to talk to you a little bit about ChemCollective's Virtual Labs. So, what exactly is this technology? What are the Virtual Labs? What do they do, and what do they enable? As you might imagine from the name, the ChemCollective Virtual Labs are basically a chemistry lab put somewhere online in a virtual world instead of in the physical world around you. It is a flexible simulation that has been translated into a number of different languages, and because it's placed online and is open source, it is available for anyone in the world. Now, because this is a virtual lab and not a physical lab, the resources that are available to students and teachers are essentially limitless. There's no concern with finances, so any chemicals, any glassware, any materials that really are needed in introductory chemistry labs are available for people who are using this software. If an educator takes the time to program in whatever resources they need, they will be available for the students using the program. Now, because this simulation is so very flexible, it's really scenario-based learning. So teachers can create their own labs, create their own procedure for what they want students to do, or their own almost like a physical resource, so their own set of chemicals and glassware and other materials available to the students, and then give the students direction either through email or in a class as to what they want them to do in this virtual lab. So it's really tailorable to whoever is designing the simulation and also to whoever is using the simulation, because you don't have to use all the resources that are available to you. Now, the virtual labs were designed by ChemCollective to be interactive and engaging for students, and really to be kind of a real-world link for students who are working on homework problems. So instead of sitting at home and crunching through a bunch of numbers and doing textbook calculations that didn't make a lot of sense and didn't have a lot of applicability, they intended the virtual labs as a supplement in homework so students could actually be working on lab work at home, just not in a lab situation. So one other interesting thing of note with the ChemCollective's Virtual Labs is that they were the 2010 Science Prize for Online Resources in Education Award winner. And that was really the year that I think the ChemCollective's Virtual Labs really took off. A lot more educators were contributing to this resource, and a lot more were starting to use this resource as well. Now, what learning theories can this technology support, and also what is its potential for learning? Again, because it is such a flexible simulation, really it lends itself well to any kind of discovery-based learning or any kind of learning in context in the chemistry classroom. So teachers can design scenarios where students need to do inquiry sort of labs and determine what different unknowns are or how they can come together. They can design scenarios where students need to apply their chemistry knowledge to do things like solve a crime scene or a murder mystery party. So it's almost like this technology has a number of different uses in addition to its intended design as a supplementary homework tool. Now, how can it be integrated into curriculum? How can it be used for learning? Really, it can be used as it was intended as a homework tool, so it can be given to students with set questions they need to go through and solve like they would a lab or like they would homework questions, or the way that I've seen it applied in other scenarios is almost as a lab supplement or lab replacement, particularly in students who are engaged in distance or online education. Instead of being mailed either a kit that uses kind of kitchen chemistry sort of tools to get a lab experience, students can log in and use this sort of simulation or something like Second Life to get that lab experience. Now, what benefits are there from using this technology, and what concerns are there in an educational setting? I mentioned previously, because this lab is happening in the virtual world and not the physical world, schools won't be limited by very expensive chemicals or glassware or other materials. So really whatever a teacher wants to implement as a lab procedure, the students can follow through and actually do that without worrying about those resources. Another benefit that was seen from the designers of the virtual labs was an increase in student engagement, and also students who were highly gifted in chemistry and in lab settings already were able to identify and correct misconceptions they had in the lab just by using the virtual lab scenario. Now, the real concern that I can see with using this would be that schools might try to replace physical labs with this virtual lab, and that really disadvantages students who could have access to physical labs. There's certain skills that you gain through actually manipulating chemicals and glassware and being in that environment, being conscious of the safety and the needs around you that you won't get from using a simulated program online. However, for students who don't have that option of doing something in person in a lab, I think this is a great tool to supplement their learning. And finally, what practical considerations are there for using this technology in an educational setting? Well, there is a bit of a learning curve as to how to use the virtual lab. It takes a bit of playing around with to kind of get an idea of how you're supposed to do things like pour chemicals from one vessel to another, how to weigh things out, those sorts of things. Also, when you're going through, you need to remember that you need to take actual physical observations in a lab notebook. You can't just assume that the computer program will do it for you. I made that mistake myself when I was going through. Otherwise, I don't see any huge drawbacks. Obviously, students will need to have access either online to do things on the website, or they will need to be able to download something onto their own personal computers to run the ChemCollective Virtual Labs. But the way that things are going in North America right now, it seems that lots of students in introductory chemistry classes, that's first year university or college, normally they have their own personal computers and they do have that access online to download these programs. Now, going through and looking at the activity, the easiest way to access the activity is actually to download the content, and I provided the link for it on the screen. Choose the file that you need, either for a Windows or a Mac. Go through the instructions on the website to download and open the program, and then load open the NaOH, so sodium hydroxide standardization homework. And you can do that by going to File, Load Homework, Acids and Bases, Standardization of NaOH. However, do not read the problem description that they've supplied. We're not going to go through all of those steps. We're going to do a simplified activity together. And what we're going to be doing really is figuring out the concentration of our unknown solution of NaOH, a strong base. Now, even though you can read a concentration off the bottle for NaOH, it's not always going to be that concentration because it's hygroscopic. It absorbs water from the air. So in a real world situation, whenever you use NaOH, you need to standardize it. You need to find out what its concentration is. So if you don't have a lot of chemistry background knowledge, the general reaction between an acid and a base is if you add your acid and your base together in equal proportions, you're going to end up getting a salt and a water. So try and write out the reaction between NaOH, which is the solution we're standardizing, sodium hydroxide, and KHP, which is an organic acid. Now, if you're familiar with chemistry, if you understand molarity and titrations, go ahead, go through, titrate KHP with NaOH twice in the precision transfer, that's the default mode, and once in the realistic transfer mode, and then post in the discussion forum your observations and calculations. We'll compare between different people what they actually got for the concentration, and I also want you to think about the different transfer modes, which is better and why might that be better. If you're not so familiar with chemistry, I'm going to go through a quick couple of steps, just like tips and tricks for what to do really quickly. Unfortunately, the video is going to get a bit longer. That's why I'm giving you the chance to bail out right now if you know what you're doing. So going back to writing out the equation, you should have something that looks like this. KHP plus NaOH goes to KNAP, that's our salt, plus water, H2O. And you'll notice that for every 1 part KHP, we're going to use 1 part NaOH. So that means that if we know how much KHP we have, we know how much NaOH is present in our solution. So 1 mole of KHP will react with 1 mole of NaOH. If we know the volume of NaOH used in liters, then we can figure out the concentration in moles per liter, because we'll know the number of moles from the KHP and the volume of the NaOH that we added to the reaction solution. So it's simple math to figure out the concentration in moles per liter. So go through, look at the solutions available in the stockroom. How can you determine how much KHP is going to react? Pause the video if you need to think about that. Now, you'll notice that you're given a concentration of KHP and the volume. Using those two pieces of information, you can find the number of moles, just doing unit conversion between those two pieces. If you multiply the concentration by the volume in liters, you're going to get the number of moles present in solution. Assemble a titration apparatus using the glassware that's available inside the simulation. If you don't know how to do that, then either do a web search, just looking for titration apparatus to get an idea of what pieces need to go where, or post a comment in the discussion board and I'll talk you through the process. Now, the other thing with doing an acid-base titration is you need some sort of clue as to when you're done with the reaction. So in this case, we're going to use an indicator. It's phenolphthalein. And when it's in acidic media, so when it's in the KHP, it's going to be clear. But then when it's in a basic solution, it's going to be bright pink. It's going to show up really well on the screen. So what color should your solution be when the titration is complete? So the titration is complete when all of your acid, all the KHP, has reacted with all the base, the NaOH. And you're going to have a couple extra base molecules present. You can't help it, you're just going to have a few lying around in solution. So because we have basic media, it's going to turn bright pink with that phenolphthalein. Go ahead, do the titration, note the volume of NaOH used. So again, you have to take initial readings and final readings. And if you don't know how to read a burette, do a web search on reading meniscus or post in the discussion board and help you with that too. Once you've done the titration once, do a second trial the exact same way just to verify your results. Try and be as accurate as possible using the smallest transfer amounts possible. Repeat your concentration calculations just to check and make sure you've got about the same numbers for both trials. Then do a third trial in realistic transfer. So go into Tools, Transfer Bar, Realistic Transfer, and repeat all those steps. It's just a different mode. It gives you more an idea of what it's going to be like in the real world, actually using a burette, actually doing things. Then go ahead and post in the discussion forum with your observations and calculations. Compare with whoever else is doing this activity. And talk about what's different between the precise and realistic transfer. Which one do you think is better and why? Now, I've posted a paragraph and it references this article here, which is the initial announcement about the virtual labs after they won that science prize for online resources and education. Happy reading! Bye, guys!